First section from Chapter 11 is titled Angle and Line Relationships. So by the end of this lesson, we're going to examine relationships between pairs of angles and relationships of angles that are formed by parallel lines and transversal. We'll have several vocabulary terms, so make sure that you're writing the definitions as well as drawing the pictures and making any additional notations that I make. Vertical angles are opposite angles formed by intersecting lines, and they are congruent. So you can see in the picture we have a pair of intersecting lines. The opposite angles, or the angles that are opposite one another, are the vertical angles. So in this picture, angle 1 and angle 2 are vertical angles. They're opposite one another. They're congruent, so they have the same angle measure. And angle 4 and angle 3 are also congruent and are vertical angles. And if we want to note that those angles are congruent, we would say angle 1 is congruent to angle 2, and also angle 3 is congruent to angle 4. So vertical angles formed by intersecting lines, they are opposite one another. Adjacent angles are two angles that have the same vertex between them. They share a common side, and they do not overlap. You can see in the picture the adjacent angles are angle 5 and angle 6. Adjacent angles can be added together to come up with a larger angle here. So we could write an equation that the measure of angle 5 plus the measure of angle 6 would equal the measure of angle ABC. And you can hopefully see, if I trace angle ABC here, you can see that that angle is made up of the two smaller angles, angles 5 and 6. So there's the large angle ABC, and it's made up of angle 5 added to angle 6. Complementary angles are two angles whose sum is 90. Remember, sum means addition, so we can add the two angles together and we'll get 90 degrees. So the measure of angle 7 plus the measure of angle 8 should equal 90 degrees. We can see that it's 90 degrees here because of the red box in the corner. Remember, that indicates a 90 degree or a right angle. Supplementary angles are two angles whose sum is 180 degrees, or two angles that add up to 180. So here we have angle 9 and angle 10. They are supplementary, so if we take the measure of angle 9 and we add it to the measure of angle 10, we get 180 degrees. So let's look at some examples. First, we want to find the missing angle measures from this picture. So we have two intersecting lines, and hopefully you remember that intersecting lines create vertical angles across from one another. So angle X would be 110 degrees, and angle Y would be 70 degrees. Example 2 says that if angle A and angle B are complementary, remember that means that they add up to 90, and the measure of angle A is 65 degrees, what's the measure of angle B? So if they add up to 90, we know one of them is 65. We take 90 minus 65, and we get 25 degrees. So the measure of angle B is 25 degrees. Number 3, now we're told that A and B are supplementary, so they add up to 180. Again, the measure of angle A is 65, but now we want the measure of angle B, or the supplement. So we take 180 and subtract 65, and that gives us 115 degrees. So the measure of angle B is 115 degrees. Perpendicular lines, this is a term that you're familiar with, are two lines are two lines that intersect and they form a right angle, or right angles, indicated there by the red box. And remember that a right angle is 90 degrees. The two terms that you might not be as familiar with, and I've done some color coding here, are parallel lines. Parallel lines are two lines in a plane that never intersect. And those are the red lines there in the picture. Transversal is a line that intersects two or more lines in a plane. So the blue line is a transversal because it's intersecting both parallel lines. A notation that you might see in the future, parallel lines sometimes are drawn with these triangles on them, indicates that those lines are parallel to one another. So this slide has quite a few definitions on it, and we want to make sure that you're writing the definitions. You've also drawn the picture, so go ahead and do that now. Write out the definitions and draw the picture, then pause the video while you do that. Then play the video as I'm explaining so you can be looking at the picture and kind of learning along with me. Interior angles are angles that lie inside the parallel lines. And so I'm going to do some highlighting and then some labeling. So inside the parallel lines, remember the parallel lines are the two lines that are going horizontally across the picture. So those are angles 4, 3, 5, and 6. Notice they are inside the parallel lines. So we're going to label those here. Angle 3, angle 4, angle 5, and angle 6. They are all interior angles. Exterior angles then are the opposite. Exterior angles are outside the parallel lines. So those would be angle 1, 2, 7, and 8. So exterior angles, angle 1, angle 2, angle 7, and angle 8. Alternate interior angles. Those are angles that are on opposite sides of the transversal, and they are inside parallel lines. And these come in pairs. So if we look at our picture again, we want interior angles, so that was 3, 4, 5, and 6, but they also need to be on opposite sides of the transversal. So angles 3 and 5 are alternate interior angles, and so are angles 4 and 6, and they are congruent to one another. So here we're going to write that angle 3 is congruent to angle 5, and angle 4 is congruent to angle 6. And remember that congruent means they have the same measure. Alternate exterior angles, very similar to alternate interior, but now we're working outside the parallel lines. So if we look at angles 1, 2, 7, and 8, those are our exterior angles, and they are alternate, so they're on opposite sides of one another. So angle 2 and angle 8 are alternate interior or exterior, as are angles 1 and 7. And again, alternate exterior angles are also congruent. So angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. Again, make sure you're writing all of this down. Corresponding angles are the last types of angles that we talk about when we're referring to parallel lines in a transversal. And those are angles that are in the same position on the parallel line in relationship to the transversal. And what we want to do here is we want to think of these angles as a foursome. Whoops, I'm going to use the highlighter. So we have the foursome of 1, 2, 3, and 4 up on top. And down below we have the foursome of 5, 6, 7, and 8. And you kind of think of these as like being on a position. Angle 1 is upper left, angle 2 is upper right, we have lower right, lower left. Similar down here, upper left, upper right, lower left, lower right. And so those angles that correspond to one another, that are in the same position, are congruent. So if we look at angle 1, angle 1's corresponding angle is angle 5. So angle 1 is congruent to angle 5. They're both in the upper left position of the foursome of angles there. So then angle 2 is going to be congruent to angle 6. They're both in the upper right position. Angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. Oops, wrong symbol. Remember, a congruent symbol is the equal sign with the little squiggle mark on top. So lots of different relationships that can be created or made, talked about when we talk about parallel lines and transversals. So let's look at another example. In this figure, lines A and B are parallel, and I failed to mark those two lines. So this is A and this is B. Those are parallel. Q and R are transversals. So now we're going to try to draw some relationships between some of these angles. So for example, for angles 3 and 5 are blank. So I'm going to go ahead and highlight 3 and 5. Look at the parallel lines first, A and B. Are those two angles inside the parallel lines or outside? Hopefully you're recognizing that those two angles are inside the parallel lines, so that automatically makes them interior angles. And then the question is, are they on opposite sides of the transversal? Remember, one transversal is Q, so we have 5 on top, 3 on the bottom. These are alternate interior angles. So now let's talk about some angle measures. We're told from the picture that the measure of angle 1 is 120 degrees. And we need to find the measures of angle 3 and 5. So you can draw a couple different relationships. There are a few different ways you can work around this problem, but if we look at angle 1 and angle 3, their relationship to one another, those are vertical angles, which means that they are equal. So for this example, the measure of angle 3 is also 120 degrees. Since we stated that 3 and 5 are alternate interior angles above here, angle 5 is also 120 degrees. So 1 and 3 are congruent because they're vertical angles. 3 and 5 are congruent because they're alternate interior angles. So all three of those angles are 120 degrees. For the next example, now we're talking about angles 11 and 15. So let's highlight those, 11 and 15. So what type of angles are these? They're not both inside the parallel lines. We actually have one inside and one outside. 11 is inside the parallel lines, 15 is outside the parallel lines. They're not on opposite sides of the transversal. So now we're kind of in a case where we have to look at where they are in relationship to one another when you talk about the foursome here of angles 9, 10, 11, and 12, 13, 14, 15, and 16. They're both in the lower right. So these are corresponding angles. They're in the same spot. They correspond to one another. So corresponding angles. And take a look at that picture and study that. Make sure you understand what corresponding means, how they're both kind of in that same position. We're told that the measure of angle 15 is 78.5. And so we need to find the measures of angles 11 and 9. And if you remember from the previous slide, corresponding angles are also congruent. So if 15 is 78.5, so is the measure of angle 11. So the measure of angle 11 is 78.5. And angle 11 and angle 9 are vertical angles. So the measure of angle 9 is also 78.5. For the final example, we're going to use a little bit of algebra, but we have the figure at the right, and we're told that the measure of angle ABD, so that's this big, large angle that's created from the two smaller angles, and I'm going to go ahead and highlight that. So the measure of angle ABD is 164 degrees. And I want you to find the measures of the two smaller angles, ABC. Trace where that is here, AB up to C, so it's the smaller angle on the left, and also angle CBD, which is the smaller angle on the right. Angle ABC and CBD are adjacent angles. Remember that adjacent angles add up to the sum of the larger numbers. So I'm going to just note here that these are adjacent. So that means when we add them together, we should get the big angle ABD, and that's exactly what we're going to do. If the first angle, ABC, is 2x plus 23, and the other smaller angle, CBD, is x, if we add those two things together, so take 2x plus 23 plus x, we should get the large angle 164. So now we want to solve this equation for x. We have 2x plus 23, and we have the plus x, and we really don't need the parentheses there, so we can erase those out. We need to combine our like terms, Here we have 2x and x, so that's 3x plus 23 equals 164. Subtract 23 from both sides. So we get 3x equals 141. Divide both sides by 3, and we get that x equals 47 degrees. And remember that that's not all you were asked to find. You're actually asked to find the measure of both of these angles. Well, the smaller one is over here on the right is x. So this is 47 degrees. But this bigger one on the left-hand side is 2x plus 23. So we need to take that x, that 47, and plug it in to get what this other angle measure is. Your other option is you could take 164 and subtract 47, and that would give you the other side. But 2 times 47 is 94. 94 plus 23 is 117. So this other angle measure is 117 degrees total. And you could check your work. 117 plus 47 should equal 64. 4, carry the 1, 6, and in fact it does. So you know that we have the two right answers, 117 and 47. And we could label our answers using these angle measures. So the measure of angle ABC is 117 degrees, and the measure of angle CBD is 47 degrees. So we examined relationships between pairs of angles in examples 1, 2, 3, and 8. And we examined relationships of angles formed by parallel lines and a transversal in examples 4, 5, 6, and 7. We will work on worksheet 11.1 in class.